Here we are going to determine what is logically equivalent to this compound statement here. And the statement reads, it is not true that Josie has both a Twitter account and a Facebook account. So one of these four other statements here is going to be logically equivalent to this one. We just have to determine which one. And the way we're going to do that is we're going to build truth tables for each one of these compound statements and then just compare their truth values. Those that have the same truth values are logically equivalent. So the first thing we need to do is we have to break up all of these symbolically and then just go ahead and build the tables. So it is not true that Josie has both a Twitter account and a Facebook account. So I'm going to deconstruct or pull out these simple statements out of here. And I'm just going to write them up here. Here's P. It looks like P, hopefully we recognize it is not true, but Josie has a Twitter account. And it's always best to go ahead and write out these simple statements. And the other one is that she has a Facebook account. There we go. So then symbolically, this is probably written as, and we could see right here, Josie has both a Twitter account and, that looks like a conjunction, a Facebook account. So it looks like we have P and Q, but of course that's preceded by it is not true. So then we go ahead and we'll write it like this. So it is not true that P and Q. So we'll write this one, letter A here, symbolically also. If Josie does not have a Facebook account, then she does not have a Twitter account. So this is an if-then, this is a conditional. So it's going to be not Q. If not Q, then not P. Josie, for letter B, Josie does not have a Twitter account or she does not have a Facebook account. This is not P or not Q. For letter C, Josie does not have a Facebook account and she does not have a Twitter account. So this is going to be not Q and not P. And finally for D here, if Josie does not have a Twitter account, then she does not have a Facebook account. So this will be if not P, then not Q. So now we're going to go ahead and build the truth tables here. We're going to go ahead and list the truth values for P and Q. Those are the only two simple statements. First half is true, second half is false. Then we alternate. Now if we look right here, we can see we have a not Q and a not P. So I'm just going to go ahead and put those in. That's just a personal preference. That's just what I like to do. We're going to need them anyway, so I might as well list them right off the bat. And of course, these negate them. Now what I'm going to do is I'm going to go ahead and build the truth tables for each one, including the original statement here, for each one of these compound statements here. So I've got it is not true that P and Q. I'm going to do this all at once, even though we've stated do inside the parentheses first, but I'm going to do it all at once, and I'll show you what I mean. I'm going to go ahead and say it is not true P and Q. So we know that for P and Q, for this to be true inside the parentheses here, both P and Q must be true. And it occurs right here. Other than that, it's going to be false. So it'll be a true, false, false, false. But of course, this negates it. So it's going to be false, true, true, and then true. Next, I'll do A. Not Q. If not Q, then not P. And of course, this is a conditional statement. The only time a conditional statement is true is when the antecedent is true and the consequent is false. So the antecedent is true and the consequent is false. So it's false right here. Other than that, it's true. And I'm just going to label this as A for A up here. I'll then do not P or not Q. That's a disjunction. For this compound statement to be false, this statement has to be false, and this statement has to be false. Or in other words, for it to be true, at least one of them has to be true. So here it's false right here, and here it's false right here. False. Other than that, it's true. And I'm going to label this as B. I'll then do not Q and not P. This is a conjunction. This has to be true, and this has to be true for the entire thing to be true. So here it's true here, and here it's true here. Other than that, it's false. And this is for letter C. And then finally, if not P, then not Q. Again, the antecedent has to be true and the consequent is false. Here it is right here. The antecedent is true. The consequent is false. That's when it's false. Other than that, it's true. And that's letter D. So if you haven't noticed already, we can see right here that your truth values here, false, true, 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 are the same for the original statement here. So we can say that it is not true P and Q is logically equivalent to not P or not Q. So it's letter B.